Hi everyone. Today we're going to be talking about symmetry on the coordinate plane. So in lesson 1 we talked about the coordinate plane and the different parts of the coordinate plane, the y-axis and the x-axis and the origin, and how they related to world geoterms. So today we're going to be talking about symmetry. Before we get started, let's do a little bit of a review. Please pause and do this review on your own and then check back in. Alright, there's no way of knowing what two opposites you chose. So I'm just going to choose 1 and -1. But opposites, remember, opposite sides of 0, same distance from 0. So describing where these two numbers lie, 1 lies 1 unit away to the right, and -1 lies 1 unit from 0 to the left. So how are they similar? They are both the same distance from 0. How are they different? They're on opposite sides. So what we're going to do to get today again is, hopefully by the end of the lesson you're going to be able to recognize when two ordered pairs differ only by the sign and how they are related to the coordinate plane and what the line of symmetry is between them. Alright, before we get started on this one, I want to talk about this word quadrant. So a couple of you mentioned it yesterday. Quad, remember, means 4. So a coordinate plane has 4 quadrants with the origin right in the middle. Sometimes we only see part of it. Like up until this year, you might have only been working in the first quadrant. So what is new this year is now you're going to be working in all 4. So it's important that you realize that you start in the positive, and then go counterclockwise. So positive, quadrant 2 is negative positive, because the x is always going to be negative. Quadrant 3, negative, and quadrant 4, positive, negative. So some people even like writing that. So quadrant 1 is positive, quadrant 2, negative, quadrant 3, negative, and quadrant 4, positive, negative. So again, when I say that, I'm talking about the signs of the coordinates. So I'm going to do the first one with you, the first one, and then I'm going to have you pause and see if you can do the other two. What we're trying to figure out is how changing one or both of the ordered pairs by just the sign affects where they're located on the coordinate plane. Okay, so the first one. If we look at these coordinates, what is the same? Well, my y-coordinate is the same. So my y-coordinate, same. What is different? My x-coordinates are opposite. Sorry, I didn't leave much room. Are opposites. Okay, and then this next part, and this is why I wanted to walk through a whole one with you. If you're not familiar with the terminology or the words, it might be a little confusing. It says similarities in location. So we're going to graph both of them. The first point was 3, 4. So remember, you start at the origin, you go over 1, 2, 3, and up 1, 2, 3, 4. So here is my first point. And my second point did the same thing, except you started with a -3 and up 4. So I'm just going to label these A and B, just so I have something to refer to. So the similarities in location. So if I look at what is the same about them, it's easy for me to see that they're both points are up 4 units from the x-axis. What is different about them? Well, they're both the same. So again, because that's hard to read, they're both up 4 units from the x-axis. The difference is that one is 3 units to the left of the x-axis, and the original one is 3 units to the right. So difference, and I hope I can write this small enough. The points are the same difference, same distance from the y-axis, but on opposite sides. And again, what was the same is there are 4 units up from the x-axis. 4 units up from the x-axis. So what is the relationship between the coordinates and the location on the plane? It's kind of all of this right here. If the y-coordinate is the same and the x-coordinates are opposite, they have a line of symmetry of the y-axis. So another way of saying that is what I have written here. If the y-coordinate is the same, but the x-coordinates are opposite, the point reflects, so the new image from the old image, or the original image, reflects over the y-axis. So y-coordinate the same, y-coordinate the same, x-coordinate opposite, reflects over the y-axis. All right, so I want you to pause and see if you can do the other 2 columns before you come back to see if you're correct. All right, let's see how you did. I've been noticing that some people just watch the video and write down whatever I'm writing without even listening to it. That's not going to help you because I say a lot in here that you need to actually hear. So I'm going to talk through this. So you need to make sure that you're pausing and writing down. All right, so the similarities for this one, this time the x-coordinates are the same, and the difference is the y-coordinates are opposites. So what is the same in their location? So here's A right here, and here's C. This time they're 3 units both to the right of the y-axis. So what is the same is they're both 3 units from the y-axis, but what is different is one is for above the x-axis and one is for below. So that's what's different. They're on opposite sides, but same distance from the the x-axis. So I actually wrote this out. So what does this mean about the location? It means that if the x-coordinates are the same, but the y-coordinates are opposite, the point will reflect over the x-axis. So here, my y, go away. Here, for the first one, when the x-coordinate was the same, we reflected over the y-axis. For this one, when the y-coordinate's the same, we reflect over the y-axis. For this one, the x-coordinates were the same, so we're going to reflect over the x-axis. Y the same over the y-axis, x the same over the x-axis. What happens if we change both of them, like this? Well, hopefully you did this, and what you found is what they have in common, their similarities, are the same distance from both axes, but on the other side, the opposite side. And if we start with A, to get to our new point, you'd have to reflect over the x and then over the y, or you could reflect over the y and then over the x. So our lines of symmetry, which I believe was a 4th grade target for you, lines of symmetry like this, if you are only changing the sign, it is going to give us a line of symmetry of one of the axes. Alright, this is going backwards. It's just hopefully solidifying how the location changes. So here's our given point. If the given point is reflected over the x-axis, that means the x stays the same and the y becomes its opposite. If it's reflected over the y-axis, the y stays the same and the x becomes its opposite. If it's reflected first over the x and then the y, both signs change, both become its opposites. And if it's reflected over the y and then the x, it still is both of them. So let's just come over here and check. Let me make it a little bit smaller. So we started right here with our S, and then we reflected over the x-axis. So M, over the x-axis, M was still 5. The x-coordinate was still 5. And the y-coordinate became its opposite. When we were reflecting over the y-axis, the y stayed the same, we were going up the same amount, but the x became its opposite signs. And when we were reflecting either over the y and then the x, or the x and then the y, both signs switched. So please fill these columns out and then come back and check. Alright, I made a little cheat sheet down here for you. So if they reflect over the x, we take our original and we keep the x coordinate the same, the y coordinate opposite. If they reflect over the y, you keep the y coordinate the same, but change the opposite of the x. So x stays the same, y is its opposite. Over the y-axis, the y stays the same and the x becomes its opposite. And then if they're going over both the x and the y, you have to change the sign of both. So this one should be pretty easy for you given what we just did. When the coordinates of 2 points are x, y, and opposite of x, y, what is the line of symmetry? Well, they share the y, so you're going up the same amount every time. So they are, the line of symmetry is the y-axis, because you are going for each point, you go up the same amount. And we could say that do the exact same thing for this one. If we start with x, y, but now the x stays the same, the line of symmetry would be the x-axis, because you're going over to the right or left the same amount every time. Alright, your exercises are really about following directions. So these first couple, you have to mark your first mark, begin at 7, 2. So 7, 2, 1, 2, 3, 4, 5, 6, 7, and up 2. And it says move down 3 units, so I'm going to go down 3 units from this point, right there, and then it says reflect over the y-axis. So here's my y-axis. So we have to flip this point so it's on the other side of the y-axis, the same distance away. So it was 7 units away, down 1, so now it has to be 7 units away, down 1. 1, 2, 3, 4, 5, 6, 7, down 1. So it's like you have that number line where 0, your axis, is right in the middle. Okay, I'm going to have you do this one by yourself. I'm going to skip because this is getting pretty long and show you what this part means right here. It says begin at -2, 3, label it A, and what quadrant is it in. So we're going to go to -2, 3. So -2, 1, 2, 3. And it is in quadrant 2. Reflect point A over an axis so that it is in quadrant 4. And label it B. Well, to go to B, to get from quadrant 2 all the way over here, you have to actually reflect it twice. So we're going to reflect it over the y-axis. So now my new point would be a +2 and a +3. And then we have to flip it over the x-axis. So 1, 2, 3. So if it's over the x-axis, the x stays the same, and the y becomes its opposite. Okay, this is what most of your assignment is like. All right, let me know if you have any questions. We out.